Well, hey everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. I know the name kind of switched up on some people, but hopefully you guys saw my post. It is still the same crazy girl with the hand that does the plan of doing math. So, if you are here, please say hello. Hello, Pog. Hello, Kelly, Spencer, Cookie. How are you? Play Big. How you doing? I'm Melody. Hello. All right, welcome everyone. So what we are doing this lovely evening, let me get my cord out of the way. We're looking at exponential functions and we're going to be doing some graphing. Now, necessarily this is not on the GEDs. Graphing, I know some people are taking classes and they're kind of getting a little stuck on this. So I will not be insulted if you're just like, ooh, Audrey, this is not me, and you want to skedaddle. Hey, that's fine. But if you want to sit, just watch, listen in for a little bit, I would greatly appreciate that as well. All right. So if anything, when we're looking at exponential, we have like a couple formulas, but the framework is basically the same. You have your y equals a times b raised to the x. Now, the a, and sometimes it'll be like a point, usually a multiplication that's happening in between here. So sometimes there's like a point there. So your a is basically your initial value. If I was talking linear, I'm talking about this is your starting point. So with this being your starting point, your b is going to be the rate. What is happening? What is it changing? Is it increasing? Is it decreasing at a certain percentage? Basically looking at what is the pattern that's happening from one point to another. Now, for the b, if it's greater than 1, then it is a growth exponentially. So think about when COVID happened. You know, it happened relatively small and then bam, it just shot up. Like, I don't know. So that's like an example of exponential growth. Now, exponential decay, if your number or your b is in between 0 and 1, so it's not equal to 0, but it's not equal to 1, it's between 0 and 1. So we're looking at your 2/3, your 1/4, your 1/10, your 2/7, okay? Anything that is below, basically between 0 and 1, is going to be considered a decay, all right? So it's almost like thinking about when you first buy a car. And as soon as you, not even completely off the lot, as soon as that first inch of that tire comes off of that lot, boom, there's depreciation on that vehicle, right? So that's like an example of the decay. If I want to stick with the COVID, kind of, all right, people started staying in, people were getting vaccinated, and then all of a sudden, instead of that growth, there was a slow decline, all right? So with all of this, there is usually a minimum, all right? There is usually a line which is called an asymptote, all right? Say it with me now, asymptote, all right? So what your asymptote is, it's a line, okay, that your graph is getting close to. It never crosses it. It can get as close as it can without crossing or even touching it. So if I think of it this way, say that you're going to the zoo, right? And there is hopefully a fence or some kind of protection between you and a tiger. Because we all know, tiger, just one swipe, you're dead, right? Let's not try to fool ourselves, right? So you have this protected glass. And of course, you always see the videos of the little kid getting real close to the glass. And look, it's a kitty. Knowing the tiger is like, I can eat that. Yeah, I can do that, right? So the asymptote is the glass. You can get as close as you want. So you want to touch the cute little kitty called the tiger, right? And as close as the tiger can get to that little protective glass. But that is that barrier. Okay, you will never cross it unless you have a door and you go through it. Now, for standard versions, the equation of the line of an asymptote is always y equals 0. Okay, so without doing any kind of movement, so the starting function, aka the parent function, will always have an asymptote of y equals 0. That's also known as your x-axis. Okay, so knowing that bit of piece, let's kind of take a look. So I want to eventually graph y equals 3 times 2 raised to the x. So if I can slide this over so you can do a little bit of comparison with our notes here. So I want to ask, is it a growth or a decay? So where I would look based off of our information here, I'm going to look at the b's. So I want to know what the b's are doing. So if you notice, I have a times b raised to the x. So the b is your second number, which is inside the parentheses in this case. So our b is a 2. So just like we said, which one of these satisfy this b? Is it growth or is it decay? You can put G for growth or D for decay. Okay. Oh, Venture with Angel. Hey, JD, how are you? Hey, Roxy. Mish, hello, hello. What do you think? Spencer, how are you? Okay. We have G. Okay. We got another G. Aaron, how are you? All right. So we've got a couple people that are saying G. It's about 50 of us in here. Take a guess. Hey, Janie. Well, hello from Baltimore. How's it going? Starting to get a little sweltering around here. Okay. I don't know. Okay, that's fine. Okay, so we got our growth. Another person saying growth. All right. So let's take a look. Today was an interesting day, but we had another great session this evening, which is awesome. You know, day 1 of the second group. So since this B is a 2, I'm coming over here and looking at my rules. So 2, is 2 between 0 and 1, or is 2 greater than 1? So, all right, well, I'm glad, Roughnut. How's things going? So since 2 is greater than 1, it's going to be growth. So all I have to do is just circle growth. So now, they're not giving me any kind of vertical shifts, okay? They're not giving me a plus a number, a constant, or minus a constant. So that means my asymptote is going to stay right where y is equal to 0. So the only way that our graphs shifts up and down from our parent function is if I have a plus or a minus outside. Okay. Did I start my class today or my live? For the class, it was 7 p.m. Eastern Standard Time. For my live, it was 9:30. Well, I got here like 9:31. All right. Okay. Hey, Janice, you're here too. Oh, my live? Yes, at 9:30. Well, today was 9:31. It's a little late. All right. So, my y-intercept, just like we have for the definition, the y-intercept is our initial value. It's our a. So the number that's in front of the parenthesis, that's going to be our a. So our y-intercept is going to be at 0, 3. Because remember, the y-intercept is when your x values is equal to 0. Okay, you're welcome. All right. So now, knowing just that little bit, knowing that it's going to be growth. So just like how I read it, from left to right, it should be increasing. But sometimes it's kind of hard for us to just sketch because they don't want us to sketch, they want us to graph. So the best thing that my suggestion will be is let's make a table of values. So what I'm going to do is just a small little table. Just going from here to here. I'm going to pick some x values. Now here's the thing. The x values is going to be the exponents. So why not make a couple of them, if you can. A couple of them are going to be positive, a couple of them are going to be negative, and one that's going to be 0. So I know some people will say, all right, well, let's keep it simple. Let's go to -1, 0, and 1. If you want to, typically most teachers will pick -2, -1, 0, 1, and 2. The reason why, you got a couple numbers that are negative, a couple numbers that are positive, and your 0. So what I'm going to do is I'm going to take this -1 and I'm going to plug it up for the x because I want to get my y value. And the only way for me to get the y value, to get my ordered pair, is to plug in something for the x and simplify. So it's going to look like this. We have 3 times 2 raised to the -1. Okay? Now, if you recall, anything raised to a negative exponent, we have to flip. So we're not flipping the 3 because the 3 is not being raised to the negative first power. It's the 2. The 2 is what's being raised. So we're looking at 3 over 2 to the first power, which is simply 2. And if you love to change it into a decimal point so it can help it a little bit more, we're looking at 1.5. So what we found is an ordered pair. The x value is -1 and the y value is 1.5. So here we go. Here's -1, here's 1, and 0.5, right smack in the middle. All right. Okay. So I'm seeing some -6s. Let's see. Why is it positive and not negative? Why is the answer a positive 1.5? Not a negative 1.5? Is that what you're asking, beautifully defined? Okay. So what happened is this -1, that's an exponent. So anytime we have a negative exponent, we have to make it positive by doing its opposite reciprocal, okay, or flipping. So that means right now it's just the 2, okay, not the 3, okay, order of operations. We have to deal with our exponents before we do multiplication. So since we have our exponent, let me zoom in a lot. So this is actually telling me 3 over a positive 2 with a positive 1. Because now that I dropped it down in the denominator, the act of dropping it down converted from negative to positive. Okay. Yes, Julio, it is summer. But believe it or not, there are people that are taking community college classes. And there's some people that are trying to get their ASVAB, get their GED. So learning doesn't stop. Okay. So since it's dropped now, you got 3 over 2, or you can divide it and get your 1.5. Okay, not a problem. So now, and you're probably like, okay, so now we got our 0. So it's 3 times 2 raised to the 0 power. What is 2 raised to the 0 power? Okay. Good. Thank you, beautifully defined. Anything raised to the 0 power is 1. Good, Omar, good. All right. So if this is 1, 1 times 3 will give us 3. Which we knew was going to do that anyway because that's our A. Okay, that's our A. So that means we have 0, 3. So that point is right here. And last but not least, we have 1. So we're going to do 3 times 2 raised to the first power. Anything raised to the first power is itself. So that means we have 3 times 2, which you guys said earlier, will give me 6. Okay. So that means you have 1 up 6. This point, and this point. Now, taking a look at our points, and remember with our graph, if we don't have a plus something or a minus something, that means my asymptote is going to be y equals 0. So if I come over here, y equals 0 is basically your x-axis. Notice the graph has a slight little turn. Okay, you see how it's very small, but you still have a turn. So basically, your graph is going to look something like this. Okay. So it's giving me the growth. My barrier, or my asymptote, is going to be my x-axis because we didn't have a vertical shift. And I just graphed a couple of points. As close to 0 without touching it. There you go. Good. As close to 0 without touching it. Let me take a quick scan. Let me just make sure everyone is okay. Okay. Rough Nut, I'm just glad you're still learning, which is great. All right, so let me unzoom just a tad. And now we're going to shift it about this much and zoom in. If you have any questions, please, please, please do not hesitate to put it into the chat, okay? Good. Hey, Danny. All right, let's try another one. So this time I want us to graph y equals 3 times 1/2 raised to the x. So once again, I want to know, is it growth or decay? What do you guys think? Growth or decay? And if you're not sure, remember, question marks are accepted. Okay, Pog saying decay. Okay. All right. That's okay. That's okay. I'm going to break it down. Let's try to break it down. Okay, so I have decay, I got growth. All right, quick mixture. So, since this is our framework, so it's y equals a times bx, okay? The b sometimes is in parentheses, sometimes they use a dot to represent the multiplication. Your a is going to be the starting value, your y-intercept. Your b is basically the changes. What is it increasing or decreasing by? So if your b is greater than 1, it'll be growth, but if it's between 0 and 1, it'll be decay. Okay? Now rise over run works for linear, okay? We're not doing linear, we're doing exponential. All right. So if we take a look here, my a is the 3. Okay, so that's my y-intercept. That's where we start. So I might as well just put that bad boy down. So our y-intercept is going to be 0, 3, because that's what my a value is. But I have 1/2. So like some of you guys were saying decay, some aren't sure about growth, but where would number 1/2 fall in the number line? Definitely between 0 and 1. So if it falls between 0 and 1, it's going to be decay. There you go. All right. So if you want to know if it's going to be a growth function or a decay function, always look for the b. The b is what tells you that. Now the 3, that is your starting point. That's your y-intercept. Okay, so your a value is your y-intercept. The b value is going to tell you growth or decay. So now the asymptote, that's that barrier. Remember the tiger? Yeah. So if I don't see a plus or a minus something after my function, that means I don't have a vertical shift. And if I don't have a vertical shift, that means my asymptote, that boundary line, will be at y equals 0, aka your x-axis. Okay, so that's where your asymptote is going to be. So, in order for us to really see our graph, we're going to need some points, okay? We can just use 3 points. Some people like to use 5 points to really show the definition, but we're going to kind of go a little low-key because I'm looking at this pre-made graph. It can only go up to 8. It's an 8 by 8 grid. So I know if I used -2, that's going to take me way off that grid. Because if I did -2, that means the 1 and the 2, they're going to flip. So that will give me 2 over 1. Okay, 2 over 1 is just 2. But then I would have to square 2. So 2 squared gives me 4. 4 times 3, that gives me 12. That's way too big off of this graph. Okay, once you get those pre-made grids, you're going to have to take a look to see, will it fit? So instead of a -2, let's kind of start with, -1, then we have 0, then we have 1. So what that means is where I see an x, I'm going to put in a -1. So this is saying 3 times 1/2 raised to the -1. But that means I have to flip my 1/2 because it has a negative exponent. So if I do 3 times the flip, which is 2 over 1, And 2 over 1 is just simply 2. Now I don't have to worry about, because this is a positive 1 as an exponent. Anything raised to the first power, multiplied to the first power, you know, it's the same. Anything times 1 is itself, okay? So that's why we simply have 3 times 2, which gives us 6. Okay. So let me shrink-a-dink this. Then we have our -1, positive 6. That's going to be our first point. So now we're going to do the same thing for the 0. So 3 times 1/2 raised to the 0 power. Okay. Now we just got to remember, what's being raised to the 0 power is that 1/2. Good. So what's going to be raised is going to be 1/2. Anything raised to the 0 power is 1. So that gives us our answer that we had before, 1 times 3, which gives us 3. It's our y-intercept, and we already found that early on. So we have our 0, 3. All right. And now if we do it again with the 1, so it's 3 times 1/2 raised to the first. So anything raised to the first power is itself. So that gives me 3 times 1/2, which is simply 3/2. And we saw that earlier, that 3/2, you can make that into 1.5. Yes, thank you, Omar. Okay, what is the definition of an asymptote, an exponential equation? There you go. Snapshot. Take it home. Thanks for the follows, guys. Appreciate it. I know right now it's summer and a lot of you guys are just like, I just need a break. I get it. I really get it. But here's my thing. There's a lot of people that are going into community college or they're going back to school and they're taking like summer courses. And it's either algebra or it's statistics. Okay, I actually helped a young lady today with statistics. It wasn't too train wreckish, but we made it through. And she like has a better understanding, which that's my goal. So a lot of these concepts that I'm going to be going over is a lot of things that people are either seeing in those college courses, because since I'm doing my course, which is to help people with their GED, the ASVAB, the ACCUPLACER, even the TEAS test, if anything, I still have room. You know, I don't want to make it too tremendously big, but I still have room, and I also have room for tutoring, one-to-one tutoring. So if you are going into anything and you want to join our course, it's 12 weeks, so we're going to be done by the end of August. And if anything, by the end of the course, I want you to sign up and take your next step. So if it's the ASVAB, it's the ACCUPLACER, I want you to be prepared for those exams. So I can give you a certificate that you can print in your own little printer and you'll be like, oh, yay, cute. No, how about let me help you do well on that exam so you can move forward with your life. I'd rather that than anything else. Okay? So let me graph. Looks like you need tutoring. Yup. GED, message me. Okay, math teacher, and still giggle when I hear asymptote. I know, same. Same. I think of the same kid that used to say it in my classroom each and every time. You're like, okay. We're going to do the asymptote. asymptote. That's exactly, overemphasizes everything. Hilarious. You have a final tomorrow. Oh, okay. Oh, yeah. That was another one. Kids love to get it like as close as they can. So funny. All right. So since our asymptote is basically the x-axis, and you could probably see, let me zoom in a little bit, especially ones in red, you see a little bit of a curvature. Just, it's really small. But it's basically saying that from here to here, and if you want to, you can also do some other points. Okay, going all the way to positive infinity there, and it's going to keep going, and it's going to ride right along the x-axis. It's not going to cross because that will be our asymptote. That's that boundary line. Yes, I do. I do tutor for pre-calc and trig. As long as it's not AP pre-calc, I cannot. All right, 8th grade math. Yep, I can do 8th grade math as well. How do you sign up? If you go to my profile, and you'll actually see my website, which says ACG Math Tutoring. TikTok does not like me showing my website. We finally got that explanation. But if anything, I love how we're supposed to have a website connected. So how am I supposed to show people how to use it? Anyway, if you click on it, it'll ask you, oh, you're about to go to a third case. Click on it again. It will take you directly to my website. And there is a contact form. You can just fill that out, and I'll get the information, and I'll get in touch with you. All right? All right. Thank you, Ramona. I appreciate that. Okay. All right. Yes, have a lovely night. So, of the first example. Exactly. Right. It really does. Especially like when you come in with a basis of 2 versus the 1/2. And you still had your A's was exactly the same. Oops, let me unzoom so you can see that. So I'm not flipping it back and forth. So my A's were exactly the same. 1 is my growth, 1 is my decay. Yep. And it is actually reflected over the y-axis. All right. Beautiful. Oh, is this 8th grade math? It depends on what you're doing in 8th grade. Because some people are doing algebra honors. So it could be that. But I usually see this in my Algebra 2 classes. But nowadays, people are moving everything's a lot faster. Who knows? You're going to have like kids at the rightful age of preschool dissecting atoms. That's going to be an interesting curriculum. But here we are. All right. Glance at the 2 graphs of the screen at the same time? Sure. Let's see if I can finagle it. In Texas, it'll be an Algebra 1 concept? Okay. Yeah, for some of our... And that's the thing. Every district is different. And trust me, trying to be an online tutor when everybody is different, every state, every district, every school, and you would think, math's math. Nope. You'll have one person, you're like, oh, okay, you're doing system of equations. Another person is doing something completely different. And you're like, wait, you're both in Algebra 1. Like, what? What's happening? Yes, we can. Oh, you're in Minnesota? Well, hello. Welcome in. I'm all the way in Baltimore, Maryland. All right, so now we're basically using a little bit of information. So I don't want you to feel overwhelmed. So I'm going to cover up so we can do a couple problems at a time. All right. So I'm going to try to fit it in here. Okay, so it says, which function represents this sequence? So we have, and let me zoom in and then I'll zoom back out. So these are some of our choices. We have f of n is 3 raised to the n plus 1. f of n is 6 raised to the n minus 1. F of n is equal to 3 times 6 raised to n minus 1. And f of n is 6 times 3 raised to the n minus 1. So first off, let's kind of look at the pattern. I think we can get, yeah, this is all of it. So let's try to look at the pattern. And it's times 2. All right. So when we're looking at this, notice the n's are basically increasing by 1s. But that's not the thing that's throwing us. What's the pattern of my a to n's? What's the pattern? Okay, it's not times 2. How did I get from 6 to 18, 18 to 54, 54 to 162? Okay, so we're saying times 3. Do we agree now? Do we see why it's not times 2? Or was the times 2 to something else? Butterfly lady, thank you. Oh, okay. All right. So if we take a look from 6 to 18, we multiply by 3. I know I'm using x's, just bear with me. Actually, let me not, because that's like my sacrilegious. Like, multiplication is not x anymore, guys. It's not. Let it go. All right. So from 18 to 54, we had to multiply by 3. Okay. 54 times 3 gives us a 162. 162 times 3. Sorry, I just got a text message. Gives me like 486. So this is your pattern. This is your rate. So that means this is not going to be my a. Remember the whole formula? A times b raised to the x. The 3's are not going to be my a. It's going to be my b. So right away, process elimination. What can we eliminate? Okay. What can we... Hey, Nicole, how are you? What can we eliminate? Okay, Nicole's saying BD. Omar is saying AC. You're saying it's D. I'm saying BD. Okay. All right. I was going to say, oh, we got something that's consistent. Nah, not that much. So if we're looking at it, the one that has the exponent, that's going to be my B. And we're saying our B should be 3. Okay? So right now, this B for option B is saying my B value is going to be 6. The reason why I know this is my B, because the exponent of n minus 1 is attached to it. If I slide over here, my B is the one that's attached to the exponent. So that's why I can get rid of B, because my pattern wasn't going up by multiplying by 6. It was going up by multiplying by 3. So that means I'm getting rid of B. And who else? Ramona's saying C. Okay. And we're also getting rid of C because my B value is not 3. These two things might be switched around. So now we kind of limit our choices. Instead of going for 4, now we brought it down to 2. So this is a process that you can use on any assessment. GED, ASVAB, SAT, ACT, okay? All the above, okay? If they give you multiple choice, remember, the way that you are solving those exams is different from how you would do an exam in a regular classroom. They don't care about the work, they just care, did you answer the question? Did you pick the right letter for the answer choice? Okay. All right, Danny, good night. Have a nice one. So what we could do is we could plug in, let's use this first one. Notice we have our n. We can plug that 1 in for the n of those two choices. If I plugged 1 in for the n, I'm going to have 1 minus 1. That gives me 0. So 3 to the 0 power will give me 1. That's what I will get for an answer choice. But that's not what's happening here. Okay? So let's see if this D is our true thing. Hey, C4. So when I plug in a 1 for the n, 1 minus 1 gives me 0. 3 raised to the 0 power gives me 1. So that means inside that parenthesis is 1. And 1 times 6 gives me 6. And we do have an answer of 6 right here. Now, sometimes I like to make sure, so I would do it for the second one. If my n is 2, okay, I'm going to come here. 2 minus 1 gives me 1. 3 to the first power, that's 3. And 6 times 3 gives me 18. And that's what we have here. So our answer choice is going to be D. Okay, process of elimination. Right now, I'm taking it step by step, so it does seem like it's a very long time. A lot of you guys knew it was answer D a while ago. Okay, don't let anybody throw their insecurities at you for you to change your answer. Be strong and be firm. Okay, be strong and be firm. Okay. So the n is like the term in the sequence. Okay. Hello. All right. So now we have this one. Let me unzoom a lot so you can see what's going on. That's the only hard thing about word problems. Just can't fit. All right, I'll read it out. So the points 0, 1, 1, 5, 2, 25, and 3, 125 are on the graph of a function. Which equation represents that function? So if you cannot read the points, if you can't read the points, then here's the thing. Make a table. This is your x, this is your y. So you have 0, 1, you have 1, 5, you have 2, 25, and you have 3, 125. Okay. Notice the x's are increasing by 1, and my y's are increasing by what? What's going on with the y values? C4 is saying times 5. Do we agree? Okay, JB. Hey, JB. Pog is saying 5. Omar is saying times 5. Good. Okay, Lacole, good. Saying yes. Ramona, yes. Love it. All right. Because all we're doing is multiplying by 5. So that pattern, that's going to be your B value. And remember, the equation is y equals A times B raised to the x. So we need something that's going to give me a 5 for the B value. And the only one that gives me 5 for the B value is option D. Okay. Thanks for sticking with me, guys. How are you guys doing? Okay. Seeing a couple hearts in there. Knows that people are still alive. That's good. All right. Good. All right, Janie. Good. All right. Now let's get with one more. All right. So the function graphed on this coordinate grid, okay, shows the f of x, the height of a dropped ball in feet after its x bounce. So I want to ask you, on which bounce, so taking a look, I'll read it out to you, but just look at the graph. On which bounce was the height of the ball 10 feet? So when was the height of the ball at 10 feet? How many bounces? Yes, good. It is going to be exponential decay. Excellent. All right. Is it ARB? Is it ARB? Or IREB? IREB. Okay. So first bounce, uno, bounce 1. So 1, 10. Good. Thanks. Keep up the good work. Good night. Thank you, Ramona. I appreciate you. All right. JB saying 1. Lisa, first bounce. How are you? Your rib? Okay. Thank you. Thank you for the correction. All right. I know. I butchered it. I'm so sorry. Okay, your rib? Good. I'm okay. I am okay. So yes, you guys are correct. At bounce number 1, the height of the ball is at 10. So let me ask you this question. What was the original height of the ball before it was dropped? So what's the original height of the ball for it to be dropped? Okay, C4 saying 25. Your rib says 25. Omar 25. Pog 25. Good. Lisa 25. Good. All right. Good. Nicole 25. Excellent. All right. Because you're looking at the y-intercept. All right. Nice one, guys. So, if anything, I think that's all I really have. I know, it's going to be a short one. Because I had like mostly the graphing. I do have some other examples. If you want me to do some more examples of the graphing, I can do that. Thank you. All right. So, if you like the design of my books, not so much zoomed up. All right, I created this math notebook. All right, so I got tired of my kids with the disorganization. I know right now a lot of people are not thinking about math notebooks because you're probably like, yeah, I got rid of a lot of them. But keep it in mind because before, I'm not going to say it, but we all know how quickly time comes. Like, look, it is practically the middle of June. Like, seriously, right? I remember when it turned February because that's when I started doing my lives here on TikTok. And what happens is I just basically take a lot of the formats and just put it inside of my books. But not only do I have space for, basically writing down notes, taking bits and pieces of like some of your papers, I also have a resource pages in the back. And the resource pages can deal with factor sheets. If factoring is not your thing and you're like, I just can never figure out what factors to use, I have a factor sheet that goes from 1 to 200, as well as some reminders like rules of integers, order of operations, okay, properties of quadrilaterals. We're looking at sector and arc lengths, as well as area and perimeter. And also the unit circle, okay? So some people will see that in like pre-calculus and maybe in algebra, definitely in trig, okay? And the same as that will go for your Pythagorean theorem, Then you have your SOHCAHTOA, and then also some of your trig identities. So, but we have all of those wrapped up in one book. So you can get it from my TikTok shop. Look at me, right? I have my own self-published. Now we got TikTok shops. I'm working on some different versions of the notebooks for the upcoming school year. It's all kinds of stuff. Now, if you like my notes, and for some reason, you're just like, you know what, Audrey, I just want the copies of your notes. Well, guess what? You can get that too. It's called Audrey's Notes. So what I do is I take all my notes that I have on my lives, and right now I have available books 1, 2, and 3. And if you notice, there's a QR code. And with the QR code, if you scan it, you will actually get the live that is associated with the work, and you can just follow along, all right? So you can use it for mediation if you are like homeschool and you want some additional resources, and maybe have a different voice saying basically the same stuff that you've been saying. Hey, Audrey's Notes is the perfect thing for you. Okay, give you a couple examples, and then of course I left some because there are times I don't use all the information, so you can actually do a little couple practice problems yourself, and then you can follow along by looking at the QR code. All right. So other things, if you need, oh, the unit circle, I know. Oh, I know. Trust me. I cringe every time I have to tutor it, but I'm starting to get a little bit better at it. As well as the sine and the cosine curves. I don't know why. I have so much trouble with sine and cosine, but I don't have trouble with trapezoid. Woo! With the tangent and secant and cosecant. I can do those, but for some reason sine and cosine usually gives me some kind of problems. But if you're looking for a private tutor, I definitely have some slots open if you want to purchase my notebooks or maybe even some courses. So I have some self-paced courses ready and available for the GED, the ASVAB, the ACCUPLACER, and also for foundational algebra, especially those that are making those transitional years, like from 8th grade to 9th grade. Yeah. All right. You can visit my website, acgmathtutoring.com, or you can just click the link that is in my profile. Now, a couple people I would love for you to follow if you're about to do nursing. A Blessed RN, she's amazing. Also for Impact Math 19, she also does the T's, that's Miss Taylor, the T's, the ASVAB, and the GED. So she breaks stuff down and uses old problems to help break down concepts. Okay, if you need a chemistry tutor, even if you're thinking about like, oh, I'm taking chemistry next year, take a look at Professor TK, because then when you do need some assistance, you already have a person in your arsenal to kind of help you out. As well as the abacus, my friend Learning with Lynette, she knows how to break down adding, subtracting, multiplying, dividing using the abacus. So we're actually looking up a nice little collab. So be on the lookout for that. If you have any pre-K or kindergarten kiddos and you're thinking about homeschooling, but you need some extra assistance, make sure you follow my girl Nancy, the online elementary tutor. She is phenomenal and so patient. Man, like the patience of Job this child has is amazing. And then my friend Robert, he is your AP Stat and AP Calculus, be it BC or AB. He's the guru, like he's it. So he just started his TikTok, and if anything, follow him so we can get him going live and like sharing all his secrets, tips, and tricks, and basically how to get from to get a 3 to get those 4s and 5s so you can get those college credits. All right. Good, Reed. That's awesome. You know, I love when people make those transitions. Yes, this year is really going fast. You're about to take the SIF test? For a good little review? Yes. Now, here's the thing. All of my lives, obviously not this one yet because I still have to download it. And then something was going on with yesterday's. I think it went through finally. But all of my lives, I haven't recorded and put on my YouTube channel. So everything from February 2nd, if you want to look at those exact lives, you can. And the subscription is free. So go ahead, you can subscribe away. Just go to Audrey Codner, ACG Math Tutoring. And then this is my schedule for my lives. I usually go Monday through Thursday at 9:30 p.m., Fridays at 1 p.m., Saturday and Sunday at 8:30 p.m. Okay, I try to keep my mornings and afternoons up and around for, people that need extra assistance. I'm available 7 days a week. So this is what I do. This is my life. All right, good. Any word problems in the New Testament of the King James Bible? I am not, but hey, culture me. I'm always willing to listen. I'm always willing to listen. So if you have any questions, please, please, please do not hesitate to DM me. Okay? Do not hesitate to DM me whatsoever. Okay? All right. Is that it? All right. Well, if there isn't any questions, if we can get it to like 10K, that would be awesome. Because I totally get it. I'm expecting like views to go down. Because all right, I'm out of school. Peace. But if you are like taking any kind of courses and you need some assistance and you would like to have a tutor, please just reach out. I will be available. Okay. All right. And if you do want to join in my GED, ASVAB, TEAS test, like math prep course, go ahead and go to my website. Just remember that from back here. Go ahead and go to my website. I'm actually going to close the doors not this Saturday, but next Saturday, the 21st. Because I don't want to bring people in halfway through and then you're completely lost because we've gone through so much. So spread the word. If you know someone that needs GED, that needs ACCUPLACER, maybe they already took the ACCUPLACER. I don't know. I don't know if I should do like a crash course for those that actually took the test one time already. I was kind of milling around that idea for a minute. So if you think that's a good idea, just let me know. Be like, hey, Audrey, I think that'll be good. Maybe like a 2-week or a 3-week type crash course and just tweaking people's thinking and just be able to pass like the GED or the ASVAB. All right. Oh, that's perfect. That's perfect. All right, ladies and gentlemen, I am going to wrap things up. It has been a day. This is day 2 of not having gas in my car because the city decided to hit the gas line, or not in my car, in my house. So they decided not to hit the gas line. So, hey, another cold shower. Love it. Okay. Well, hey, Gen X Todd, how are you? All right, I'm just about to wrap up. So, if anything, have a good night. Keep being awesome, guys. I know, and be careful. Because now, it's starting to get warm out. People just don't know how to act sometimes. They just think that they're the only ones on the road. They think that they're the only ones around because, it's all nice and sunny outside. So please be careful, okay? Especially, it doesn't even matter night or day. Just be careful, all right? Okay, guys. Have a lovely evening. Okay, need my services soon? Okay. Well, let me know. Just let me know. Go ahead and message me and let me know what you're doing. Because I'm hoping I can help. Because if it's calculus, no, you need to get Robert. All right? Okay. Awesome. All right, guys. I'm going to finish this up. Oh, 111. There it is. Angel numbers. All right. Have a lovely evening, and I will see you guys tomorrow at 9:30 Eastern Standard Time. All right. Take care. Bye now.